Select the structure of the first tetrahedral intermediate that is formed in the following reaction. So to approach this problem, it's asking us about the mechanism of the reaction. So we need to take a look at what we're reacting and what we're reacting it with. So if we take a look at our starting material, we can see that this is an ester. And we are reacting this with lithium aluminum hydride. And what we are forming is a primary alcohol. And so lithium aluminum hydride is a source of nucleophilic hydride. Right, so hydride itself is H minus, and this is too small to be a good nucleophile. So if you're using just a hydride by itself, as in sodium hydride, that's going to be a strong base, but not a good nucleophile. But lithium aluminum hydride, as I mentioned, is a nucleophilic hydride, and so it is a reducing agent, and this is a very powerful reducing agent. So this will react with even things like esters that are not particularly electrophilic of carbonyls. So this is a very powerful reducing agent. So to start this mechanism, we need to know the structure of that. So lithium is the counter ion, and so this is the nucleophilic hydride portion, is this aluminum with the 4 bonds to hydrogen. And so what this is going to do is it's going to transfer a hydride to the ester carbonyl. And so we can see there's our ester. And this first step is typical of all attacks on a carbonyl. So your nucleophile, in this case the hydride, will attack the carbonyl and break the pi bond. And so the very first structure you get here is the intermediate that you're being asked about in this problem. So we can see that we had a neutral oxygen. We put an extra lone pair of electrons on there, so it now has a negative charge. We still have that methoxy group, so you still have that OCH3, and we have added a hydrogen. So this is actually as far as we need to get for this reaction. So I'm going to go ahead and identify the right answer, but then we're going to go back and we're going to finish this whole mechanism. So this intermediate here looks like C, where you've got here's your carbonyl carbon, you've got your negatively charged oxygen, you've got your propyl chain. I mean, it's showing it on the opposite side, but that's fine. You've got your OCH3 group and you've got your hydrogen. So it's definitely C. But let's go ahead and finish the mechanism so we can understand how we get that primary alcohol. So whenever you get to a tetrahedral intermediate, so we'll go ahead and label this as the first tetrahedral intermediate. If there is a good leaving group on that intermediate, then the electrons can come back down from that oxygen to reform the carbonyl and kick off your good leaving group. And so that methoxy group is a good leaving group. And so what we have formed now is we've kicked off that OCH3 minus, and we formed an aldehyde as an intermediate. And now aldehydes are even more reactive than esters. So we can expect, if lithium aluminum hydride is a powerful enough reducing agent to react with an ester, it's definitely going to react with an aldehyde. So we can show again this aluminum hydride doing the same sort of attack on the carbonyl, so transferring the hydrogen, and we're going to get another tetrahedral intermediate. So we have, again, an oxygen with a negative charge. We've got the hydrogen that we added in the first step. We've got another hydrogen. And this is really close to the primary alcohol. So to get to the primary alcohol from here, we are adding in an acid, and we are going to protonate that. And so this, we know that nothing further happens before we add the acid, because in this tetrahedral intermediate, you don't have a good leaving group. You're not going to kick off a carbon or a hydrogen with a negative charge. So this will just simply sit in solution until you have added the aqueous acid in the workup step. So we can protonate that, and that would give you your primary alcohol. You're also going to form an equivalent of methanol here, because this OCH3 that you kicked off is also going to be in the solution as an anion, and it will also get protonated in the exact same way.